Hello students, how are you? Okay, let's start the chapter Thermal Properties of Matter. First of all, you should know what is heat. Heat is a form of energy which produces in us the sensation of hotness or coldness. According to dynamic theory, heat may be regarded as the energy of molecular motion, which is equal to the sum of total of the kinetic energy possessed by the molecules by virtue of their translational, vibrational, and rotational motion. Now, Joule's mechanical equivalent of heat. What do you mean by Joule's mechanical equivalent of heat? Whenever a given amount of work W is converted into heat, always the same amount of heat Q is produced. Thus, W is directly proportional to Q, or it can be written as W equal to JQ. The proportionality constant J is called Joule's mechanical equivalent of heat. Joule's mechanical equivalent of heat. It may be defined as the amount of work that must be done to produce a unit quantity of heat. Thus, J equal to 4.2 into 10 to power 7 erg per calorie, or it can be written as 4.2 joule per calorie. Now, temperature. What do you mean by temperature? It is the degree of hotness of a body. The temperature of a body gives a measure of the average kinetic energy of its molecules. Absolute scale of temperature. The lowest possible temperature of minus 273.15 degrees centigrade, at which a gas is supposed to have zero volume, and at which entire amount molecular motion stops, is called absolute zero of temperature. The temperature scale which starts with minus 273.15 degrees centigrade as its zero is called Kelvin scale or absolute scale. The size of degree of Kelvin scale is same as that on Celsius scale. Kelvin equal to 27 temperature T plus 273.15 degrees centigrade. Triple point of water. What do you mean by triple point of water? The triple point of water is the state at which the three phases of water, namely ice, liquid, and water vapor, are equally stable and coexist in equilibrium. It is unique because it occurs at a specific temperature of 273.116 Kelvin and a specific pressure of 0.46 centimeter of Yagi column. Constant volume air thermometer. It is used to measure the pressure of a definite mass of air at different temperatures. The volume of air remaining constant. It is based on the pressure law. That will be equal to P upon T equal to P0 upon T0, or it can be written as T equal to T0 P upon P0. In terms of triple point of water, T equal to T triple point into P upon P triple point. Ideal gas temperature scale. Ideal gas temperature scale. The ideal gas temperature on the Kelvin scale is defined by the T equal to limit P triple point at 273.16 P upon P triple point. It is independent of the nature of the gas. Now, linear expansion. What do you mean by linear expansion? When a solid rod of initial length L is heated through a temperature delta T, its final, meaning increased length, will be given by L dash equal to L under bracket 1 plus alpha into delta T, where alpha is coefficient of linear expansion and alpha is given by alpha equal to L dash minus L upon L into delta T. The coefficient of linear expansion of material of a solid is defined as the increase in length per unit length per degree rise in temperature. Now, superficial expansion. It is also known as areal expansion. When a solid sheet of initial surface area S is heated through a temperature delta T, its final, meaning increased surface area, is given by S dash equal to S under bracket 1 plus beta into delta T, where beta is the coefficient of superficial expansion and it is given by beta equal to S dash minus S upon S into delta T. It is defined as the increase in surface area per unit surface area per degree rise in temperature. Now I am moving further the next topic. The next topic is cubical expansion. What do you mean by cubical expansion? When a solid of initial volume V is heated through a temperature delta T, its final, meaning that increased volume, is given by V dash equal to V under bracket 1 plus gamma into delta T, where gamma is coefficient of cubical expansion and it is given by gamma equal to V dash minus V upon V into delta T. And gamma can be defined as the increase in volume per unit volume per degree rise in temperature. The coefficient of cubical expansion of an ideal gas is equal to the reciprocal of its absolute temperature, gamma equal to 1 upon T. Relation between alpha, beta and gamma. The three coefficients of thermal expansions are related as alpha upon 1 equal to beta upon 2 equal to gamma upon 3. Then beta equal to alpha and gamma equal to 3 alpha. The units of alpha, beta and gamma are same and it is per degree centigrade. Coefficient of apparent expansion of a liquid. Coefficient of apparent expansion of a liquid. It is defined as the apparent increase in volume per unit original volume per degree rise in temperature. Gamma alpha equal to apparent increase in volume upon original volume into rise in temperature. Now, coefficient of real expansion of a solid. It is defined as the real increase in volume per unit original volume per degree rise in temperature. Gamma R. It is defined as the real increase in volume per unit original volume per degree rise in temperature. Gamma R. Gamma R means what? Coefficient of real expansion of a liquid, and that will equal to real increase in volume upon original volume into rise in temperature, where gamma G is the coefficient of cubical expansion of a gas. Variation of density in temperature. How would vary the density with variation of temperature? The density of a solid or liquid decreases with the increase of temperature. Rho dash equal to rho 1 minus gamma into delta T. Now I am moving the next topic, specific heat. What do you mean by specific heat? It may be defined as the amount of heat required to raise the temperature of unit mass of a substance through 1 degree. If Q is heat and this heat is needed to raise the temperature of mass m of a substance through delta T, the specific heat C equal to Q upon m into delta T. In SI unit is joule per kilogram per degree Kelvin. Heat gained or lost, Q equal to mc into delta T. Now molar specific that previously I have told you about specific heat. Now I am telling about molar specific heat. Molar specific heat. It is defined as the amount of heat required to raise the temperature of 1 mole of the substance through 1 degree. Previously I told you it may be defined as the amount of heat required to raise the temperature of unit mass of a substance through 1 degree. Now in molar specific heat I am telling it is defined as the amount of heat required to raise the temperature of 1 mole. Mind it, 1 mole of substance. If Q heat is needed to raise the temperature of n moles of a substance through delta T, then molar specific heat capital C equal to Q upon N into delta T. In SI unit is joule per mole per degree Kelvin. Now heat capacity or thermal capacity. What is heat capacity or thermal capacity? It is defined as the amount of heat required to raise the temperature of a body through 1 degree. It is defined as the amount of heat required to raise the temperature of a body through 1 degree. Heat capacity equal to mass into specific heat. That will be m into c. Water equivalent. What do you mean by water equivalent? The water equivalent of a body is defined as the mass of water which requires the same amount of heat as it required by the given body for the same rise of temperature. I am repeating once again the statement. The water equivalent of a body is defined as the mass of water which requires the same amount of heat as is required by the given body for the same rise of temperature. Small w equal to mass into specific heat, that will be m into c. The SI unit of water equivalent is Kelvin. Now, latent heat. What do you mean by latent heat? The amount of heat required to change the state of unit mass of a substance at a constant temperature is called its latent heat. The amount of heat required to change the state of unit mass of a substance at a constant temperature is called its latent heat. It is denoted by capital L. Now, latent heat of fusion. What do you mean by latent heat of fusion? The amount of heat required to change the state of unit mass of a substance from solid to liquid at its melting point is called latent heat of fusion. Latent heat of vaporization. The amount of heat required to change the state of unit mass of a substance from liquid to vapor at its boiling point is called latent heat of vaporization. When two bodies at different temperatures are placed in contact with each other, the heat lost by the hot body is equal to the heat gained by the cold body. This is the law of calorimetry. This is the principle of calorimetry.